Welcome back to another thrilling episode of Math 068. This is Professor Needing, and tonight we're talking about determining the difference between a parameter and a statistic. So in section 7, we talked about the notation involved in a parameter statistic, and tonight we're going to make an application to that. So let's start by doing just a little bit of review for what we're doing. So we'll start on page 49, and in page 49, we need to talk about the difference between this population and a sample. Now notice a population, we use the word parameter to talk about its statistic, but in a sample, we use the actual word statistic. They're both statistics, but one goes with a population, one goes with a sample. So let's talk about the mean value. So in a mean, the sample statistic was always X bar. In X bar, that was some average value for a sample statistic. Well, in a population, that's a mu value. The standard deviation of a sample set was S, but the standard deviation in a population was sigma. In a single proportion, it was a p hat, but in a single proportion for a population parameter, it was capital P proportion. When we're talking about two data sets which contain means, and we're comparing those two data sets which have means, we're going to use what was referred to the difference in means. A sample statistic uses a difference in means, so therefore, the X bar of the first set, sub 1, minus the X bar of the second set, sub 2. It's not always 1 and 2. It can have letters associated with it, or it can have words associated with it. In a population, that would be the mu of the first minus the mu of the second. Same for difference in proportions. Since we use proportional data here, we're going to calculate the difference in those proportions of two sets or more. P hat of 1 minus p hat of 2. And for a population, p of 1 minus p of 2. When we talk about correlation coefficients, remember in a sample, that was R, and in a correlation coefficient, that was rho for a population. Rho can also be listed with that funny P. I'm not very good at it, but I'll try it. There is the rho value. I like to just use rho to clarify. So in this for this exercise, we're going to work on that stuff. It says for each of the following studies, identify both the parameter and the statistic using appropriate notation. Okay, it's going to be a little bit involved, and we'll take care of it. A sociologist wants to know the proportion of adults with children under the age of 18 who eat dinner 7 nights a week. What I'm trying to talk about are all of those people right there. The population isn't just as easy as simply saying P equals. It's identifying the group of people that we're looking to imply something to. Notice it's also a proportion. So our parameter P is adults with children under the age of 18 who eat dinner together 7 nights a week. All of that is required in order to identify the population parameter. We found the population parameter. Now we're supposed to find the statistic that goes along with that. Now remember, the statistic is part of the sample. We keep reading. A simple random sample of 1,122 adults with children under the age of 18 was obtained 337 of those adults reported eating dinner together. Remember that if we're talking about a proportion in a sample, this is my statistic. My statistic is p hat. P hat is 337 reported it out of a sample of 1,122. 337 divided by 1122 as a decimal is approximately, and it doesn't say how much, 0. Let's go with 300. So the statistic that goes along with this parameter is approximately 0.300, or about 30%, or 337 over 1122. This is the statistic we report. And this is the parameter we're trying to make a best guess of. For B, a school administrator wants the mean, that's important, right? The mean score on verbal portion of SAT for those whose first language is not English. So right away, I can see my parameter. Now remember, my parameter is a mean. When we talk about a parameter of a mean, right here, when we talk about a mean, my population parameter mu, that's what I'm looking for, and my statistic that's going to go along with it is x bar. Now we're given a value, or we're looking for a parameter which says those verbal portion of SAT for students whose first language I think it said is not English. Should have capitalized English. And again, what I'm identifying right now is I'm identifying the parameter. And the parameter for this would be mu. That's what I'm looking to find. Looking to find that score of that verbal SAT for the students who are non-speaking English as their first language. So a mu gives an x bar response as a statistic. And that statistic is going to be, I got to go find it. So from a simple random sample of 20 students, that's not it. That just tells me n, whose first language is not English, the administrator observed a mean sample of 458. The statistic that correlates to the population parameter. Letter C. Suppose the Cartoon Network is conducting a nationwide survey to assess viewer attitudes towards Superman. Using a simple random sample, they selected 400 boys, 300 girls to participate in the study. So right away, I have two groups. I have two categories. You're either in the boy category or you're in the girl category. To participate in the study, 40% of the boys say that Superman, so first of all, percent means proportion, right? Proportion, percent. Of the boys say that Superman is their favorite character, we're comparing 30% of the girls. Okay, well, clearly we have p hat values here. So the p hat values we have correspond to proportion values for the population. So the population parameter is going to be P1 minus P2. That's what the population parameter is going to be. And what is it going to measure? It's going to measure the difference in proportions of boys and girls who do what? Who report Superman as their favorite character. Report Superman as their favorite, and it did say character. Funny, I remember to capitalize Superman, but I didn't remember to capitalize English. Okay, so if this is the population parameter, then we need the proportional values. Well, the proportional values are p hat 1, which was boy, minus p hat 2, which was girl. P hat of boys was 40%, 0.40, minus girls, who was 30%, 0.30. So p hat 1 minus p hat 2 is 0.10. The difference in proportions of the sample is 10% or 0.10. It matters because in the story, boys were given first, girls were given second in both instances, so therefore P1 is boy and P2 is girl. Don't turn them around. So boys were 10% higher, that's the positive number. If we turn those around, we'd have negative, which means they would be 10% lower, and that was not the case. The last one I'm going to do for you, and then the rest will be for you to include as part of your student upload. Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus. Researchers want to estimate the proportion of patients taking Nexium that are healed within 8 weeks. So right away, I'm looking for proportions. A random sample of 224 patients suffering from acid reflux disease is obtained. 213 of those patients were healed after 8 weeks. We're not looking at two different proportions, we're looking at a proportion here. So when we talk about the population parameter is going to be a p-value, and it's going to be based on estimate the proportion of patients taking Nexium. So it's going to be the proportion taking Nexium who are healed in 8 weeks. For that population parameter, we're going to use a p hat value, and we're going to go find that p hat value. The sample was 224 patients suffering from acid reflux disease, 213 reported being healed. That's what we're looking for, healed. So it's 213 out of 224. 213 divided by 224 is approximately 0.951. I'm just carrying 3 decimals. So approximately 95% of those in the sample were healed of acid reflux after 8 weeks of taking this particular drug. For your remainder, please finish page 51 and finish these and write them up exactly as we did in class and make those part of your upload. I'll see you in the next section, which is finding confidence intervals through bootstrapping.